Live from the desk of Lady Ada by PiZero Hackaday Contest Edition.
Hey everybody, and welcome to another Desk of Lady Ada. As introduced by Mr. Lady Ada, we're broadcasting live yet another in this series for the Hackaday Pi Zero contest. Would you like a Pi Zero? Would you like one for free? Would you also maybe like to have a chance to win a $100 gift certificate in the Hackaday store? Well, you can. All you have to do is enter the Hackaday.io Raspberry Pi Zero contest that's running right now through March 14th, and you can win both a Pi Zero and a gift certificate. The 10 most well thought out, best documented projects that are up on February 24th are going to win one of 10 Pi Zeros. And then on March 14th, there's going to be a final drawing for one of 3 grand prizes of a $100 gift certificate to the Hackaday store. So you could win both prizes. And you can even submit your project to the Hackaday Prize, the big Go to Space contest of 2016. So you can get a head start on that. This is a great reason to start designing your project. You don't need a Pi Zero to enter. Just come up with an idea, sketch it, draw it, prototype with something else. You can use anything you like to get your idea down onto Hackaday.io and then prototype with your free Pi Zero, or pick one up and then win the grand prize. So very exciting contest.
Okay, and just for folks who never heard of a Raspberry Pi Zero, it's a $5 low-cost computer. Basically runs Linux and other things. But this gets you started, and it's very rare right now. The demand is so high that there's not that many. So we figured, let's give some away. So that's the contest. The place that you win is Hackaday.io. Lady Ada is giving them out. And right now they're up to 81 entries, which is really good.
Good, but they always need yours. So if you have an idea, enter. I think that there's a lot of stuff not covered, a lot of ideas that could be mined into fruition, and I'm excited to see what people come up with. So yeah, Pi Zero contest, it's rocking out. And check out the previous videos we've done. This is our 7th video. We've done 6 videos that take you through the hardware, setting up your distro, audio outputs, digital inputs, video, pretty much all the really cool stuff that you can do with a Raspberry Pi Zero. So that's kind of what we're doing here. We're just doing 10 videos to get you started, inspire you with some ideas and some solutions to common problems.
Yeah, people say ideas are cheap, but in this case, the ideas can earn you something pretty rare.
Yeah, so you can give a Pi Zero and $100. I mean, that's good idea. Return on investment.
Okay, well, let's start to kick it off. What are you going to show off tonight?
So tonight we're going to talk about analog inputs. So the previous video we did, I think maybe 2 videos ago, we did digital inputs and digital outputs. So I showed you how to blink an LED and get button presses and have that button press do something, and that's all well and good. But the chances are you want to connect maybe some sensors. And so tonight we're going to show 2 ways that you can connect an analog sensor into your Raspberry Pi. We're going to show the cheap-ass way, and then we're going to show the more professional way. Choose which one you want. One only needs a capacitor, another one needs a chip. And also check out Tony DeCola's tutorial, I'll show it on the screen shortly, all about analog inputs for your Raspberry Pi, which goes into even more high-end analog digital inputs. But the Raspberry Pi does not have native analog inputs. This is why you kind of have to do a little bit special stuff to get that going. Not too bad, though. I'll show you some techniques. So let's go to either the computer or quad. It's the computer, and I'll quickly scroll through this tutorial. This is showing you the Hackaday Pi Zero contest. Check it out. It's contest 9326, and it goes through all the rules. So, of course, read that through, and then you can learn how to enter the contest as well. Don't email me your project. It won't count towards winning. You have to put it up on Hackaday.io. So the first method I wanted to show off, it's super simple, but it works pretty well, is the RC timing technique. And the RC timing technique basically means if you have a resistive sensor, and here's a couple of resistive sensors, a FSR is resistive, a flex sensor, a photocell, a thermistor, a potentiometer. These are all sensors that act like resistors. There's no chip inside of them. They're not driving an analog voltage. It's just, when you bend The flex sensor, the resistance changes. When you squeeze the FSR, the resistance also changes up and down between, I think, like 1K and 20K. A photocell, when you cover it with your hand, the resistance changes. So let's basically go to the overhead, and then I'll kind of show you how this goes. This is pretty easy. Got the hover cam. Okay, I'm going to grab my multimeter. So, hold on, get into ohms mode. So if you have your multimeter, and you connect a photocell to the leads, you'll see that it has a resistance of, say 2.5K. And then when I cover it with my finger, it goes down to 10K, it goes up to 10K. And when it's lit, it can be about 2K. And this is not even super bright. If I point it towards the light over here, it will drop down. So basically, the resistance of the photocell changes with how much light's hitting it. So what we can do is a fun hack, which is you basically use the resistor part of the sensor to charge and discharge a capacitor. And let me grab a capacitor here. So this is a let's use a 10 microfarad capacitor. You could use almost any value. I'll show you how to pick the value. And this goes to ground. Oh, sorry, wrong way. So you've got the capacitor from ground to the resistive element, and then just make sure I super get this wiring right. Hold on, let me get some wires. I want to match the code to the way I have things connected. Okay, so the positive side of the resistor goes to 3.3 volts. And the negative side goes to ground. Make sure you get that right. So this is connected to ground. And then just to explain really easily what's going on here, you've got this 3-volt line. This is an adjustable resistor. This is your capacitor. And what you can do is quickly connect this I/O pin. So this is your I/O pin. Connect this I/O pin to ground, and then you float it. And then when when it's ground, you basically remove all charge of this capacitor. And then when you float it, it slowly charges up until it hits the halfway point between 3 and ground. And then the I/O pin can trigger that input and then continue the cycle. So let's connect this up to pin 18. You can use any GPIO pin you like. Isn't that nice? Okay, so we're all set here. So that's good. So now let's go to quad screen. And I'm going to look at the voltage on this pin. So I've got my scope is looking at the voltage on that pin, which is 3 volts. That's because nothing's going on yet, so the capacitor is fully charged. So here is the code that we're going to be running. It's real easy. Basically, you have some, you can call RC time on the pin. You zero out your reading. You set the pin to an output. You set it low. That clears out the charge from the capacitor, the voltage from the capacitor, and then you wait a small amount of time just to make sure that you're completely ready to go. You can actually, I guess this isn't really necessary. You don't need to sleep, but I think for just happiness, I did that. Although it delays things, and then set up that pin to be an input. So now it's floating, and then you're just waiting while that pin is still low, while the capacitor is charging up. You increment your count, And then when you're done, you just return the count. That's pretty much it. So you're just counting how long it takes to go from 0 to whatever that input trigger value is, which is about 3.3 divided by 2. So let's grab this code. Create a new file. Oh, this is all off, but let's see if Python cares. Yeah, I got it indent properly. 1 second. You know, I downloaded the Atom processor, the Atom code editor for Windows, so going forward, there might not be so much Emacs. Okay. So it's printing out numbers. It's about 2,000. When I cover it, the value goes up to like 16,000. So definitely that value changes. And then let's see what's going on here. Oh, I just have to, this is so fast. Okay, so here is, let me turn off my cursors. Cursor's off. Off. So you can see here, this is when that, this point here is actually when the pin is brought low. It's brought low and then, you know, you return the value. Was it brought low? Yeah, I think it's brought low at the very end. The voltage gets up to, let's measure the peak to peak, 1.32 volts before it triggers, and then it drops down. So as I cover up this sensor, you see it takes longer because the resistor is larger, less current is going to the capacitor, it takes longer to charge it up. It of course also has to do with the capacitor size. The bigger the capacitor, the longer it's going to take to ramp up. 10 microfarads is a pretty good, you know, amount for most resistive sensors. Most of them range from about 1 to 10K. But this is a very basic way to do sensor readings. Now, because we're not dealing with a real-time operating system, you know, the Linux is doing stuff in the background, your readings aren't going to be precise. They're going to vary a little bit. And every once in a while, if, you know, something's going on, the kernel needs to write the disk, and it's not getting to the Python code fast enough, you know, you may get a larger value than others. So this is where you'd want to take multiple readings, maybe toss at the highest, toss at the lowest, average them, keep a running average. If you care, if you just want to see, like, is it light or dark, then it's not a big deal. You can also use this with a potentiometer. So let's remove this, and then remember you want to only connect to 2 of the pins of the potentiometer. And then we will wire it up like so. And then you can see as I twist the knob, it gets longer, you know, the resistance goes high, and this is, I think, 10K. Of course, when you go down too low, it actually, you know, it starts shorting the value. So you know, I think probably under 100 ohms, you want to maybe put another resistor in series. But this is a perfectly fine way to add a basic potentiometer input or basic resistive sensor input. And the good news is you can do it on any GPIO pin. You've got like 15 pins to go with. All right, so that's demo number 1. The only downside is you can't use it with some other sensors. Like this is a sound sensor, for example. This sound sensor doesn't act like a resistor. It has an analog voltage output. Because it's an analog voltage output, you can't use it to charge a capacitor because it's not like no resistive source or anything. So you know, we have a couple of sensors that are analog sensors sometimes. Some temperature sensors, like the TMP36, is a analog output. You can use a thermistor, which is resistive, and that would work really well. You'll just have to calibrate it. But if you want to use like a sound sensor, that's not going to work. You have to actually have a true analog digital input. So we're going to wire that up next. While I'm doing that, is there any questions, Phil?
Let's take a look at the various chats.
Let's look at the various chats. So I'm just going to wire this up, and then we'll go over it because it's taking me a few minutes to do this.
Okay, It looks like some folks are still waiting for their Pi Zero from the Magpie. And that's interesting because the Magpie is the first magazine that included a computer on its cover. That was in the UK, I believe. That was the only place they did it, and they included a free Raspberry Pi for an issue.
Yeah, but they haven't gotten them yet, or?
Yeah. I think some are still waiting.
Yeah. Okay.
Yeah, that was like $70 for a 6-month subscription, and you get a Pi issue number 40, and you get a Pi Zero. So that's one way. Okay, next up, how does the Pi Zero compare with the current Raspberry Pis that are available?
It's the same speed and capabilities as the Pi Model 1 and Pi Model 1 B and B+. It's going to be a bit slower than the Pi 2 because the Pi 2 is a quad-core processor, and the Pi Zero is a single core. But you can do quite a bit. It's still, 700 megahertz, clockable to 1 gigahertz processor. It's not too bad. We actually did a MIPS comparison of like how fast the processor is, but you can Google for that. And you can compare it to like a Pentium processor and stuff like that. Okay, hold on.
Okay, next question. What's a good analog multiplexer IC so we can use multiple analog devices on one set of pins?
Well, you can use this chip I'm using right now. The MCP 3008 gives you 8 analog inputs. So that's a good analog input technique. Okay.
Can we use the Pi to measure current? If so, how?
You can. Actually, the chip I would suggest to do that with is the INA 219. If you're dealing with under 26 volts, positive or negative. The INA 219, I just love that chip. It's got voltage and current measurements. It'll measure the voltage. It has, put a resistor on it, and it'll tell you the current, and it's I squared C, so you don't even need analog inputs. Or you can use, a current coil, and then you would have to use analog inputs, and you want a precision analog input as well. Hold on. D out goes to 23. I'm getting all these pins totally wired up. And then DN is probably 24. And then chip select shutdown is going to be 25. Okay. All right, any more questions or ready to move on?
Is this on Twitch? Yes. It's on
Twitch.
twitch.tv/Adafruit.
Yay. Okay.
And happy Valentine's Day to everyone out there. We decided to stay so far away from any restaurant in New York City because it's deadly.
I know, everyone, I think, didn't we go once and there was like a breakup?
We went on accident because we're just like, oh, it's going to be like a nice chill night. And
where did we go? We're like, and it was actually not so bad. We went to like some place, it wasn't like a steak place, it was like, didn't we go to like the Vietnamese place or something, and it was just like super chill because like nobody really goes to the Vietnamese hole in the wall. Good food, but not very romantic.
Yeah. New York City's deadly because it's a big deal day for like restaurants. I think Valentine's Day and Mother's Day are up there. And they're just meltdowns. It's just the way it is. Lots of joy, but there's another side of that coin that is usually seated directly next to you.
Okay. All right. So let's go to back to us, back to the electronics. Electronics will always love you. So the next tutorial we're going to do is actually we have 2 tutorials for this. One is an older one, one is a little newer. The older one is just like raw bang version, and this is the nice Python version that Tony DeCola recently wrote up. And this tutorial, Raspberry Pi Analog Digital Converters, coincidentally published only a couple days ago, has basically a nice Python library for the MCP 3008, which is an 8-channel 10-bit ADC with SPI, so it like works really well. And there's also an I2C ADS 10x15. So the ADS or I2C, there's only 4 channels, but you get 12 or 16 bits. Whereas this chip I'm using right now is SPI, it only does 10 bit. Now, do you need 16 bits? Maybe you do. But if you do, you know where to go. You go to the ADS 1115. It's a lot more expensive. It's surface mount. You can't through-hole prototype it. That's why I'm going with the MCP 3008. It's a lovely little chip. You can get it from anywhere. This chip is SPI, but it's very simple SPI, so you can bit bang it, so you can use any pin. So I'm not actually using the SPI hardware interface. I'm using 4 pins for clock, data in, data out, and chip select. You can use any 4 pins, and you can multiplex them. It's very easy to do. For simplicity, we're not using the SPI device. So that way you can use this with something that does use the SPI device, like LEDs or a display. So this is the wiring for it. It's actually kind of a nicely arranged chip. The channels are on the left, channel 0 through 7. There's 1 ADC and it's multiplex, so just be aware of that. I don't believe it's actually 8 analog digital converters. It's very rare to have that. It says multiplexed 8 channels. VDD, that's 3.3 volts in this case. VREF, you can change this, but for the most part, keep it to 3.3 volts. That's the reference voltage. You'd only reduce that if you're dealing with smaller voltages and you want to adjust the range. Analog ground, connected to ground, clock, SPI clock, data out, data in, chip select, shutdown. These are your control pins. And data ground, digital ground. So connect that to ground as well. And this is the wiring I'm going to be using. You can also use hardware SPI, but I'm not doing that. And then we have a Python library that's kind of easy to use that you can install. I already did that on here because, of course, I wanted to check. Oh, did I? No, I deleted it. Huh. All right, I guess I have to install it. Let me git clone this. I might have grabbed another SD image. I'm up. How come I can't git clone? Uh-oh. That's not good. Hold on. That's weird. Oh no. I have internet, but I don't have internet. Shoot. All right, hold on a second. I will, let me do a quick Wi-Fi setup. Adafruit? That's weird. Hold on, technical difficulties. Let's bring it back up. If not, I have other solutions.
If you like improv jazz, you'll love electronics.
Do, 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 do. Yeah. Okay, that works now. You can get clone, or you can just download the master. It doesn't matter. Go into that. Where was I? And then install. Kind of nice. It installs a package. Package management for Python is exciting and adventurous. Maybe one day, if all of you are good boys and girls, we'll have a whole video about that. Or maybe if you're bad boys and girls, I don't know. So you can also install via the package index, which is fine, whatever. So let's go to the examples. Oh. And then we'll run simple test. So simple test is simple. It looks like it definitely did get the MCP 3008. but it doesn't actually have data coming into it because it's just floating. I can mess with that by just touching channel 0, and you can see channel 0 is now going a lot higher. I will change this to just do one channel. Let's sleep 10 milliseconds. Don't print all the values. Print values 0. Okay. So I can tie this to VCC to read the highest value. The highest value to read is 1024. And if you tie this to ground, the lowest value is 0. So what I will do to make reading a little bit easier is make it print out stuff. See if this works. It's been a while since I did. Okay. So now I just have it, so you don't have to read the text. I have it printing out these lines so you can see this is the value in stars. I just print out stars so you can see like a line. So this is if you connect it to 3 volts, okay, all. And then if you connect it to ground, none. So when I just touch it, I'm just like inducing some voltage on there. So let's connect up this analog microphone. So I'll just connect it.
You know the stuff on your screen to the left is going bonkers, right?
Yeah, it should be.
Bonkers.
Yeah, because it's floating. So in a second it won't. So enjoy the bonkers while it lasts. Let's power, let's see, VCC, 3 volts. And then let's grab a ground wire. Green for ground. Tie that to ground. So, don't forget that this microphone has a DC bias, and that's why you're seeing about like half the screen. So now when I touch the microphone, it will do stuff. So you can see that I rub the microphone to kind of induce some noise. Audio noise, not voltage noise. You'll see the lines go back and forth. Just to make things happy, let's change this to mic val equal value 0, and then mic val equals absolute values minus 512. So basically get rid of the DC bias. And then
There's a request to speak into the microphone.
I will, but I gotta get it working first.
So what you're saying is if you speak in the microphone, it's not working, it might not produce the results.
I know. Well, I want to get this like working, and then I'll do that. So now we have it so it doesn't have that DC bias anymore. So that's kind of nice. And then I'm going to make it a little bit faster, so it's more reactive by removing. Oh, you know what? I should also I'll have the scope, so you can visualize it on the scope too. Okay, so you see when the noise on the microphone shows up on the scope, squizzle squizzles shows up over here on the computer screen. And then when I talk into it, especially if I talk loudly, you can see that it picks up that noise. So I don't know if this would be good for, recording analog voice. It probably isn't fast enough. I don't know, I'd have to look at the kilosamples per second. But you can definitely determine when there's noise in the room, maybe do some very basic analog input. Not going to be hi-fi, but maybe good enough for your voice detection circuit. And that's it.
All right, that's everything?
Yeah, that's my demo. So that's 2 ways.
That's perfect.
This is like that Thai restaurant that closed down that we were like going to. We're going to go bring us back to the restaurant. They had this great dish called duck 2 ways, and I'd get it every time. It was like a duck, it was like a curry duck, and then they also had like a sliced duck. It was like they basically took a little bit of duck and they prepared it in 2 different methods, 2 different curries, and it was awesome. This is analog for your Raspberry Pi Zero 2 ways. You get the resistive input version. It's low cost, easy, just needs a capacitor. Good enough for basic stuff. You can connect to any digital I/O pad, and then we've got the fancier analog input where you can have any kind of sensor input and read it as fast as you like.
No
Beep, beep.
No ducks were harmed in this filming of Desk of Lady Ada. I can't speak to others, though.
Quack.
Okay, well, that's it. Check out hackaday.io. Enter your ideas to win a Raspberry Pi Zero because they are hard to find. We'll be around on Wednesday for Show and Tell, Ask an Engineer. Thursday is 3D Hangouts, and we'll have a few more of these videos. And then after we're done with these, because we're almost wrapped up with the 10 videos, we'll go back to just the randomness of the Desk of Lady Ada.
It's going to be awesome. We have so many projects that we're going to work on. It's unbelievable.
Yeah, there was a request for another like home electronics repair.
Yeah, I got to find some broken stuff to fix. And stuff is a little easier. It usually lasts a little bit longer. I can fix another one of those brother printers. We have like 3 of them.
No, I have some things that are. I have some retro stuff that I want you to take apart and maybe do something with, and then there's some things that should probably be repaired.
Okay, great.
Yeah.
I'm on it. So we'll fix some stuff. We're going to hack some stuff. I want to work on my Princess Phona. Going to get to that since I have the Phona Feather done. Internet of Things.
Yeah.
Projects.
All the people out there, don't forget, go to hackaday.io. And if you like these videos, hit like and hit subscribe. It actually is a way we measure things. If folks don't do that, then we'll stop doing it. We'll just actually do this without the cameras on.
Know.
And that doesn't really help the world because at some point this will be used as a hologram in the future, and probably there'll be a virtual Lady Ada teaching. So think about the future children. Think about the future children, the hologram children.
Let's go into space. So yeah, we're going to do a couple more videos. I have some plans. I'm going to do an Internet of Things one, connecting your Pi to the internet and sending and receiving data. Maybe I'll demo that with Adafruit.io. Shoot, and I think I have some other stuff written down. We did actually pretty much everything that I was really into. Maybe I'll do one about like controlling neopixels and stuff, since that's probably going to be requested, and that's kind of an interesting little hack as well. If you guys, if anyone watching, if you folks have suggestions, of course, post them up in the comments. We'll take a look at them. We have a couple more videos, and thank you, Sophie and Adam, for hosting this contest. It's been so much fun doing these videos.
Okay, and before we go, there is one last thing.
Oh, what?
Yeah, I'm going to go to the...
You want a cat cam? Was it cat?
No.
Oh, yeah. Cat's not even here.
Cats. I don't even know.
Cat's been a jerk.
Yeah. This is that poster that Joe Kim from Hackaday did. So hold this up.
No.
And say thanks to Joe Kim.
Thank you, Joe. This is awesome. I'm going to hang it up, and it's just super cute and lovely.
Yeah.
And we appreciate it.
This is actually going to be the first thing we see in the morning and the last thing before we go to sleep. So that, I think, is a definition of good art, is when you know it's going to be seen and used by a lot of people. And I think, for me, the use of this that's super cute. I mean, like, it has everything that...
It's got cute robots. It's got cute drones.
Yeah. Like,
it's got the logo you designed.
Yeah, this is electronics for everyone. And I just think this is, it's drones and robots and engineering and Raspberry Pi. I mean, this is just really cool. So
thank you, Joe.
Excellent work, Joe. And just amazing artwork. And thank you again, Adam and Sophie. Okay, I'm going to send them this link after we're done, too. Bye-bye.
All right, thanks, everybody. Have a great night.